Hi, in this video I'm going to show you how to calculate z-scores, and we're going to work on this problem here, example 1.36 from the book. It's about SAT scores. It wants you to calculate, I want you to find, let's see, what proportion of all students had SAT scores of at least 820. And it says the average, the mean SAT score is 1026 and the standard deviation is 209. So we want to know what proportion had at least 820. So this curve here shows us the proportion that had at least 820. So here is some value 820. It's below the mean, right? So it's to the left. The mean is 1026. So that's right in the center of our density curve. So 820 or better would be this bluish area here. And we need to find that proportion. So here's how we do that. We need to know a few things, right? One of the things we need to know about z-scores is that when we look up z-scores in our table A, they're going to give us the value to the left, the proportion that falls below. In this case, we want the proportion that falls above, got at least this score or higher. So this is a tricky problem to begin with because we need to know that fact. So we will calculate this by figuring out the area to the left first, which is what the table A will let us look up, and we're going to subtract that from the total area. So we have our whole curve, the area to the left of 820, which is the scores below 820, the proportion of scores below 820, and that'll give us the actual area to the right. So this is the way we calculate values that are greater than something or at least something. The first thing we need to do is to standardize our score, our 820 score. In order to standardize it, we take the value 820, we subtract the mean, and we divide by the standard deviation. So in this example, the z-score is going to be our value 820 minus the mean, which, let me see, that was 1026, all divided by, I think it's at 209. 209 was our standard deviation, so 209. So there's the calculation we want to do. So 820 minus 1026 So we get a z-score of negative 0.985. We're going to use two digits, so we're going to round that to negative 0.99. So that's our standardized value. What that means is that the value 820 falls approximately, I mean, this is just about -1, right? So it falls approximately 1 standard deviation below the mean. That's what the z-score tells us. How many standard deviations? It's in units of standard deviations. So our value, 820, was about 1 standard deviation below the mean. When we did our calculation here, we saw that 820 was 206 SAT points away from the mean. If our standard deviation is 209, that means it's basically 1 standard deviation away. And that's how we get that standardized value, which is so important. because now we can, if we had another student, we could calculate that student's ACT score. And we could look at where that ACT score compares to an SAT score by standardizing the value. So the ACT scores might be like 28 or something like that. That is hard to compare to the SAT scores, which are in the hundreds, right, if not thousands. So the z-score allows you to take two unlike things, could be anything, weight versus height, and you can standardize those into units of standard deviations. Right? Now our z-score is negative 0.99. That's how many standard deviations. So we're in units of standard deviations, and now we can compare unlike things, and that's the great value of the z-score. So continuing on here, we've found that this value, 820, is about -1 standard deviations below the mean, right? So that's not the proportion, that's not the total area to the left. So we need to find this total area here, right? We need to find this area and subtract it from the whole area. That -1 is not that proportion. To find that proportion, we're going to have to look it up in Table A. So here is Table A. This is found in the back of your textbook, or you can find it on Stats Portal. There are 2 pages to Table A, values that are below the mean and values that are above the mean. So we have negative values for below the mean, positive z-scores above the mean. The table, as you notice, only goes up to about -3.4. And if you remember, you're looking at these density curves here, we find that it's less and less likely to find values above basically 3 standard deviations, right? So the likelihood of finding something above 3 standard deviations gets close to 0. So that's why we don't have these z-scores running out to like -5 standard deviations, because the values basically go to 0. It's very unlikely. So in this table, we can now look for -0.99. So the left column, we search down and we look for -0.9. So here's our value here, -0.9. And now the top here, that shows us the next digit behind -0.9. So we want -0.99, right? So this one, this first value here, if we came down, this would be -0.90, this would be -0.91, 0.92, etc. So here is -0.99. So we come to this value of 0.1611. And remember that all of these proportions are values to the left. So here's our z-score of -0.99. This area here is 0.1611, right? So this is the proportion. The whole area under the density curve area is 1, right? That's our probability. All of our probabilities must add up to 100% or 1. So now to find this area to the right, or greater than 820, as we showed up here, we're going to take our value for 820, or below, which we found to be 0.1611, and we're going to do 1 minus 0.1611. So I get 0.8389. So this is this area, about 0.84, right? So about 84% of the people will have SAT scores above 820. right? About 16% would have SAT scores below 820. Right? If you continue on in these examples, there are other examples in the book that show you how to find areas maybe between 820 and 1080 or something like that. Right? So you can find this area. And you do it by simple math, right? The math looks like you have a lower value, you have an upper value. Right, so all of our z-scores show us the area to the left. And in order to find this area in the center here that we're looking at, we would take this whole big area and we would subtract this small area from it, right? And that would give us this area here. So I should have reversed these and drawn a subtraction sign, but anyway, you get the picture.